Hey guys, I had a question about section 7.1. So what I thought I would do is walk you through the practice problem that I put on Canvas, worked out for you. So I wanted to go through one of these, so maybe it'll help you understand about confidence intervals. Estimating a population proportion is 7.1, and then section 7.2, you guys are estimating a population mean using a confidence interval there. So the first video, let's focus on proportion. We'll focus on this first problem, well actually this first page. Okay, so for this first problem, it says in a study of the accuracy of fast food drive-through orders, McDonald's had 33 orders that were not accurate among 362 orders observed. Construct a 95% confidence interval for the proportion of orders that are not accurate. Okay, so the first thing you need to figure out is you need to find the best point estimate for the population proportion. Okay, the best point estimate for the population proportion would be the sample proportion that we have found through this data, and that's p hat. So how many orders were messed up? 33 out of a total of 362 orders. So when you divide here, you get approximately 0.091, which when you convert that to a percent is 9.1%. So the best point estimate that we could give for the population proportion P is p hat, which is 9.1% of the orders, you know, we would assume would be not accurate. Now then, the next three parts talk about, you know, coming up with what we call a confidence interval. And in order to do that, we have to figure out the margin of error. And then once we figure out the margin of error, we add and subtract that from the p hat value, and that gives us sort of an interval of numbers that our population proportion would fall between, we would think. Now this is based on the confidence level that we are looking at, and for this particular problem it's a 95% confidence interval. Okay, so what does that mean? That means that your alpha here is going to be 0.05. And how do you get alpha? You take 1 and you subtract off your confidence level, and that gives you your alpha value. So since this is a confidence interval, it goes on both sides of P, we've got to split our alpha in half, and that gives us, if you take 5%, you split it in half, you'll get 0.025 or 2.5%. And your Z score, or the critical value, is 1.96. That's Z sub 0.025. And I can take you to StatCrunch to show you where that critical value comes from. It's 1.96. I'll take you to StatCrunch, and you're looking for the Z-score with 0.025 or 2.5% of the area on the right-hand side of that Z-score. So you would go here, just like we did in the last unit. You would go to calculators, you would go to normal, and to find your Z-score, you're going to be on the standard normal curve, so your mean 0, your standard deviation is 1, and we want the area to be to the right. You could do it to the left, you just get a negative Z-score, and it's 0.025 or 2.5% on the right-hand side. So there's your cutoff Z-score. That's your critical value there. So on the other side, it would be negative 1.96. So that's where the 1.96 came from. Right here, that's our Z sub alpha over 2, or our Z sub 0.025. So that's our critical value there. Okay, let's keep going. All right, now, in order to calculate the value of the margin of error, we need to figure out this Z sub alpha over 2, which we already have. in this case. And, you know, if you're wondering where this formula came from, if you look on your formula sheet that I've given you for this particular chapter section, this gives you the formulas here. Here's your capital E. That is the error, the margin of error. And it's z sub alpha over 2 times the square root of your p hat times your q hat over n. Once you get your error, you're going to add that error to your p hat, and you're going to subtract that error from your p hat. And that's going to give you sort of the interval that you're looking for. Okay, so let's flip back to the problem at hand. Okay, so we already figured out our z sub alpha over 2. For this problem, it's 1.96. That's where this came from. And then we have to multiply that times the square root of p hat. Now, our p hat is our sample proportion, which is, it's what we got up here. It's the 0.091. Now, your q hat is basically just 1 minus p hat. So you just take 1 and subtract off the p hat, and that gives you 0.909. And the n, little n, is the number of orders, total number of orders that we were looking at, the total number in your sample. So that's the 362. So we substitute these numbers into our error formula, and we get, if you type this in your calculator correctly, now be careful typing it in, okay, you've got this 1.96 times the square root, 0.091 times 0.909 divided by 362. You should end up getting your margin of error to be 0.03. Now, it's pretty easy to construct the confidence interval once you get your margin of error. What you do is you take your p, the little p hat that you have up here, the 0.091. You take the error that you got, which was the 0.030. You take the p hat and you add the error to it. That gives you the right bound. And then you take the p hat and you subtract the error, and that gives you the left bound. So then you put your population proportion in between. So when you do the math here, you get 0.061 is less than the population proportion, which is less than 0.121. Okay, so this is what we call the confidence interval. Now you can write it like this, as sort of like a compound inequality. You can write it in this format. And let's see on your formula sheet. I think it shows you that. Yeah, so you can write your confidence interval. Here's where you subtract the error and then you add the error. You could write it p hat plus or minus the error. You could write it using the parentheses here. So either, you know, either which way you would like to do that, it is perfectly fine. I think my stat lab is going to ask you a certain way of typing it in. So any of the three methods would be fine. I didn't write it on here, but you could have put p hat, which is 0.091 plus or minus 0.030. Okay, and so then what you do is you have to write the statement that correctly interprets the confidence interval. So you'll use that little statement. I think I gave you on your notes several incorrect ways of saying the confidence interval, and then you want to make sure your wording is correct. So we are 95% confident that the interval 0.061 to 0.121 actually does contain the true value of the population proportion P. Okay, now we could have done this on StatCrunch. So let me take you to StatCrunch, and we could have actually had StatCrunch calculate this for you. So what we'll do is we'll go to StatCrunch, and you'll go to Stat, you'll go to Proportion Stats, you'll go to One Sample, and we don't have the data, we just have the summary of the data, so you'll choose With Summary. The number of successes, we would consider a success to be an incorrect order or an inaccurate order. So we had 33 out of 362. So the number of successes was what? 33. And the number of observations, the total number of orders we looked at was 362. Now, we're not going to do the hypothesis test yet. That's our next chapter, chapter 8. So you're going to click confidence interval for the population proportion, and you want to enter your confidence level, which they'll tell you they wanted a 95% confidence interval. So it's actually defaulted 0.95, and you don't have to change this. You want to leave it standard walled, and you'll click compute, and you'll get your there's your p hat. Okay. Your standard error is not the same thing as your margin of error. Okay, this standard error is the sampling distribution standard deviation. So this is the number that you got when you took the square root. So this times the 1.96 gives you your margin of error. And then here's your lower limit for your confidence interval, 0.061. And here is 0.061509, whatever. And then the upper limit is 0.1208, blah, blah, blah. So StatCrunch will actually calculate the confidence level of the confidence interval for you. I hope this helps. Thanks.